All right, so thank you all very much in here and out there for returning after lunch. So what I'm going to present today is a very simple, straightforward idea, but I hope that at least in principle I can convince you that it's quite an important feature of our modeling exercises that we hopefully can make some contributions toward better managing. So this is joint work with Lena, who can't be here, but János is somewhere in the room, I think, back there. Okay, so János is also part of this team. And I'm just going to get started by briefly iterating over the motivations to do structural analysis. I mean, given the time zones that some of our online participants are in, motivations seem to be quite high to do this kind of work. And what we like to think about it is that, well, they facilitate some kind of academic rigor because they require us to take a stand on what kind of economic mechanisms we do deem important for a particular question of interest. And then increasing slowly the level of ambition then, of course, is that we not only want to study the mechanisms that we include in our models, but also use them to predict the impact of public policies. So one of the challenges in this line of work is the role of uncertainty. So there are numerous sources of uncertainty when working with structural models, and at this conference and as well as the summer school, we've had some examples of where these uncertainties come from. So for example, Jaroslav's presentation was focusing on the model misspecification, but there's of course also a lot of work in the background regarding numerical approximation errors when we solve these kinds of models. So going forward, when I talk about sources of uncertainty in our analysis, what I'm referring to is actually the parametric uncertainty that remains about the true parametrization of the model after we calibrate or estimate it to data using simulated method of moments, maximum likelihood, and the like. So what we are doing here as economists, that we often use what is called, or what Mansky in his 2021, in his very recent Econometrica article on making econometrics useful for decision making calls as-if decision making. So we'll just evaluate the implications of our model, be that policy predictions or also our assessment of the relative importance of different economic mechanisms at our point estimates. And so that includes myself. So if at any point during this presentation you feel that I'm too judgmental, I'm always including myself in any criticism that comes up here. So the consequences of doing this as-if optimization then that we potentially accept fragile findings as facts. There's the potential that we are all very, very sure about the results coming out of our models. If we don't account properly for uncertainty, and that might have a negative impact on kind of the discussion that we can have about what our particular models are useful for, what kind of predictions are reliable in a particular context, and maybe for which different models are required. So these knowledge gaps then are potentially not identified because we do not have a particular close look at the uncertainties involved. And this paper then we also want to take a positive approach by then accounting for or documenting the uncertainties, but not stopping there, and instead also framing policy advice properly as a decision problem under uncertainty. And as I already mentioned, so examples of the as-if analysis we have had quite frequently at the summer school, at the conference, and also characterizes my own, all my other work, okay? So coping with uncertainty, as it turns out, once you start thinking about it, is actually using, or is a prerequisite of using computational models in a whole host of other sciences. So for example, here are some requirements posed, or it's made explicit in some requirements put out by the National Research Council in the 2012 review of making complex decisions using computational models, but also its European counterpart, the SAPEA, is also emphasizing the need for accounting, or the need to account for uncertainty before any output from computational models is used in political, or is used to inform political decision-making processes. And the examples are numerous. So we have examples from weather forecasting, climate science, but also engineering. And when this this project started, then we initially just started out by looking what are all the other sciences doing and trying to see what are their off-the-shelf solutions and which are maybe tailored to the kind of models and problems that we encounter here as economics. And we could draw a lot on the computing infrastructure that is frequently used for uncertainty quantification in particular climate science and weather forecasting, but also just simply their textbooks. Okay, and all that was very helpful. But at this stage of the project, we also now have something that we as economists can contribute to all these other sciences here, and that's the use of statistical decision theory. So while other sciences are very much focused on documenting uncertainties in their predictions, now as economists, I mean, the name of Mansky, of course, that's no coincidence here, have this toolkit of statistical decision theory to manage these in a systematic fashion. And that's what we're trying to do as part of this paper here as well. So the contributions that we hope to make here is that we develop an approach that deals with parametric uncertainty and frames model-informed policymaking as a decision problem under uncertainty. And we'll use the seminal model by Keane and Wolpe in '97 as kind of an empirically motivated and influential, well-known test case. And what we do then is we document considerable uncertainty in the policy predictions and highlight the different kind of policy recommendations that we get from applying different forms of decision-making under uncertainty. I mean, the related literature, just already mentioned Jaroslav's work, but there's of course also Thomas' work on sensitivity analysis. And one of the features that I really want to bring across in this presentation here was also confirmed by our discussions last night, is that looking at these uncertainties is not a negative message that there is a lot of uncertainties, no, we have the tools to deal with these uncertainties, and we do learn a lot of interesting economics about the underlying sources of uncertainty in our models. Okay, so it's a learning opportunity as well as the toolkit is available to deal with these in a systematic fashion. All right, so let me start with the modeling framework. This is all going to be pretty standard and straightforward. So at a very high level of abstraction, our structural economic models just provide a mapping from parameters to some quantity of interest. So in the context of the career decision of the young men, the model would be a dynamic model of human capital accumulation. The parameters that play a particularly important role would be the estimated value of the discount rate, for example, or returns to education, cross occupation experience, and the like. And we might be interested in a particular quantity of interest here, the small y, which in our application would be the average level of final schooling in our population. And what we see here is that we often estimate these models or a model that describes the status quo and then use them for counterfactual policy predictions. So we go from our baseline model M here to the MG, which modifies this mapping by means of some policy intervention. So this policy intervention in our application later is the targeted tuition subsidy of particular subgroups in the population, but could also, as in the paper with Moritz, for example, be a mandatory schooling reform. And then throughout, there's of course a true parameter vector. This is the theta naught right here, but we can only learn something about applying this model to data about an estimate of this true parameter. And so we're going to later adapt some ideas from robust optimization to use confidence sets to construct what we then or what's called in that literature uncertainty sets that allow us to deal with remaining uncertainty about the true parameter given our parameter estimates, and to then potentially provide you with some insights about how the policy predictions compare and how to account for the remaining uncertainty about the true parameter. So let me just illustrate this with this little graph here. So where on the x-axis we have our parameter of interest. This is a one parameter example. So let's think about it in the context of educational choice, maybe as the discount rate. And there we see that we have a parameter estimate as the x-axis that describes or that maps our policy intervention into a counterfactual quantity of interest, our y hat g here. And that would describe the usual approach that we take when analyzing the policy predictions from structural model. We have a point estimate, and then we simulate our model at that point estimate, conducting some kind of intervention, and look how does the counterfactual quantity of interest look like. So in particular, if we maybe also have an alternative policy, maybe targeting a different subgroup or a different policy instrument altogether, then there's also such a mapping that translates parameter into counterfactual predictions. But at the point estimate, both of these alternatives seem to produce exactly the same value for the counterfactual quantity of interest. However, if we then acknowledge some uncertainty about our true parameter here, not just restrict attention to the outcome or a comparison of policy outcomes at the point estimates, then we are concerned now, how do we actually rank these policies, right? Because if the true parameter maybe is a little larger than our parameter estimates, then as long as more is better, we would prefer the first policy, while the opposite would be true if the true parameter is below our point estimate here. And that's now where statistical decision theory comes in, that allows us to aggregate the performance of these policies over the whole parameter space and resolve these uncertainties in a systematic and transparent fashion. So based on this model, so what as the common approach, again, it's also my common approach in the other papers that we're doing, is that we would do what's called this as-if optimization. So at the point estimates, we compare the predictions from our model for alternative policy implications, and then more is better, choose the policy that produces the highest value of our quantity of interest. So that's the status quo in most settings. And now one of the suggestions from in Mansky's recent paper in Econometrica are these as-if decisions with set estimates. And this paper is really a great resource. So if any of the issues here that maybe not our paper, but at least the issues here raised and discussed, then please have a look at at this paper. It really opened my eyes for a lot of the issues that we try now to explore and bring to a structural microeconometrics. So the idea then is to use the estimated confidence set to construct uncertainty sets that then select a subset of the parameter space based on the straightforward idea of hypothesis testing. So we're just going to consider not the whole parameter space, but instead restrict ourselves to the subset or the subset of parameters that we cannot reject with a certain level of confidence. Okay, this will also be, of course, one of the shortcomings of our approach, that we need to set this level of confidence, and I'll address that in a second here in a little bit more detail. So what we found, or we were actually coming from this operations research literature that has been using this approach for quite a while now, but at least until this paper and some other papers that we're working on, these connections between these fields weren't explored in a systematic fashion here. So what we'll do then is, as you see from this plot here, we need now to make a decision of which policy we prefer, even though it's not that one dominates the other with respect to its outcome, for all possible values of the true parameter that we, using this uncertainty set, confine ourselves to compare them. Okay, and then there are some common criteria in the literature. The max-min criterion, for example, would then select the policy that maximizes the outcome under the worst case realization of the parameter inside of the uncertainty set here. And then there are two common alternatives. So the minimax regret rule, where we would just compare the outcomes of these policies against choosing the best policy in each particular setting. And we want to minimize the maximum regret that we have from choosing a particular policy. And last but not least, we also have the subjective Bayes criterion, where we just have to put a prior distribution over our uncertainty set and then aggregate the outcomes using the predictions from the model. Oh, sorry. Yeah, great. Thank you very much. Please go ahead.
Just a clarifying question, Philipp. Is the confidence set, the U of alpha, is that a choice variable in this problem?
Yes, the alpha is. And then, so the alpha is, so the level of confidence is, and then with this, we use this to treat it as the uncertainty set going forward. So it kind of adds another layer of sensitivity on it, right? Then later you would want to investigate the ranking of your policies with respect to the choice of your alpha parameter.
Right, but I guess what I had thought was that, like, the shape of that confidence set could also be influenced by, like, I don't know, asymmetry in my loss function, say, or something, right? Like, that's, if I think about sort of traditional way of thinking through.
So in principle, you would have two choices. One is probably the more controversial in the from a decision theoretic perspective. It's the choice of this alpha, right? Because from a pure ex ante decision theoretic analysis, you wouldn't want to restrict your full parameter space, right? You would want to derive a decision rule that works optimally for all possible realizations here. So here, this is this core distinction between the ex ante perspective that you have in the classical statistical decision theoretic setting and this compromise here where we have this ex post perspective. So we did learn something from the data and code it in the estimated confidence set, where one particular choice is not only the shape of the confidence set, but also the choice of this alpha. And in some related work, now that here we document these considerable uncertainties and tackle this problem using the setup that I'm describing here, we're then working with theoretical econometricians, for example, now in a follow-up paper to endogenize the choice of the alpha, to at least get rid of that. Yeah. All right, but here it's this key distinction. Standard decision theoretic analysis would do the whole state space from an ex ante perspective before any data is realized. And here it's after we learned at least something from our models, but still want to restrict ourselves to consider only parametrizations for our analysis that are not too far out. Okay. All right. Anything else? Okay. All right. So then maybe we'll just move a little quicker about later when I discuss the results, but here the conceptual point I think is very important. So we're going from the perspective of uncertainty about the parameter to uncertainty in the prediction and how the shape of the mapping encoded by this M1 and M2 translates into uncertainty in the predictions from the model. So now if we simulate our sample, our model, the parameter space that we are considering as part of our uncertainty set, then this translates into, if you look at the top of the graph here, for the first policy, the uncertainty in the prediction is much, much higher due to the nonlinearity of the mapping that was captured there. And also in our empirical application, the shape of this mapping differs very much across different policy alternatives. Okay, and in this setting here, then now applying the statistical decision theoretic criteria, as if optimization, we wouldn't have a clear preference for either of the policies. They both have the same outcome, but under maximizing the worst case outcome, for example, we would prefer the second policy and there have a clear preference for it. And for the minimax regret, we would then prefer the first policy because on the left-hand side, the regret of adopting it is largest over the whole uncertainty set, but it's at least lower than the regret of adopting the second policy at the upper end of the uncertainty set. Okay, all right. So then in the end, we come to these rankings of the policies based on different decision theoretic criteria. And as we aggregate their performance over the whole uncertainty set. All right, so the empirical setup, that's where I'm going to be very, very brief. So we're going to build on the Keenan-Woolpin model, the career decisions of young men. And just to remind everyone, I mean, it's been repeatedly mentioned already in this summer school in particular. So we have individuals that enter the model at age 16, and then in each year can decide whether to pursue or continue their education or work in the labor market in the white and the blue collar occupations. And then Michael and Ken use this model to predict and understand the effects of numerous human capital policies. They, of course, use this as if optimization approach. And now the question in this setting, how do we determine the confidence set? So again, timing was of the essence here. So there's a recent paper in the Journal of Econometrics forthcoming by Woutersen and Ham, who tells us how to sample, how to create these uncertainty sets in a statistically proper way with the right coverage and everything. So what we'll do is we draw a large sample of the parameters from the model or from the asymptotic distribution of our estimates, then keep the draws that are elements of our estimated confidence set and construct the confidence set for the prediction based on the maximum and minimum realization over the sampled draws. And that's the implementation here. Of course, there's a lot of computational burden involved here, and maybe in the end, if I have time, then I could tell you a lot about our follow-up projects to tackle some of those with our colleagues here from the math department. All right, so that's the empirical setup. Let's look at the results. How does this then work in practice? So the original policy setting adopted in the paper was that we're looking at an effect of a tuition subsidy of $2,000 with the goal to increase average final schooling. And then just as the authors, we'll start with a general subsidy that we pay to the whole population, and then compare in a second step alternative subsidies that are just targeting either of the four types that are included in the model. So this is the point estimate that also it's very close to the one that Michael also reported in his paper. So that the tuition subsidy paid to everyone in the model, or available to everyone in the model, leads to an increase in average final schooling of about 0.6 years. And this is the point estimate, but once we start to account for the uncertainty in the estimate as well, using a 90% confidence set, here it ranges all the way from 0.2 to about 1.1. So that's only the first step, right? So this is the how you can deal with uncertainty in predictions, but also when you make claims about the importance of competing economic mechanisms, for example. So in the second step, now we think about more about decision making. So we now have different policies at our disposal, targeting either of the four different types. Because if you recall that in the original paper, and again, we're able to reproduce that without a problem, the role of types was very pronounced, and the types differed with respect to the kind of path or careers that they pursued. So let me just draw your attention here to type 1 and type 3, because that's the one that we're going to narrow in on here in a second. So type 1 has a pretty good, or is pretty keen on continuing his or her education here, as they do spend a considerable amount of the 50 periods that they live in our model actually in school. While for type 3, the time spent in school is a little bit less pronounced. And you see how that translates into the occupational choices as well, because type 3 then mainly works in a blue collar occupation, while the large majority of type 1 individuals pursues a white collar occupation. So the as-if ranking of the different policy alternatives is as follows, that we'll look at the prediction coming out of the model for the different four types. We would think that in particular, a policy that just targets type 1 individuals has a very low impact on average final schooling. So our quantity of interest that we declared for this analysis in the beginning, and type 2, type 3, or type 4, there's much more bang for the buck, so to speak. However, now looking at the uncertainty associated with these predictions, we see also that the uncertainty differs across the different types. Okay, that yes, type 1 has a very low predicted increase in average final schooling at the point estimates. The uncertainty associated with that prediction is also much lower than for the other types. And so when we now try to focus on type 1 and type 3, we'll see how the uncertainty about the impact on type 1 as well as type 3 looks like. So we have a very well-centered distribution of effects predictions here for type 1, while it's much more different, or very different shape for type 3. And as you see already, there's also quite a lot of predictions coming out of the model when sampling from our uncertainty set here that are much lower than the worst prediction for type 1 individuals. So now coming to this teachable moment, and of course we went back to the model trying to understand why is the prediction uncertainty so different between the two groups. And then we learned, which then is pretty obvious. So type 1 has a much higher baseline level of schooling than type 3. But as you also see here, the initial final level of schooling in years before the reform, before the subsidy, there is a few people that drop out of their college, even though most of the individuals do continue up to college. And those we get all of them in all scenarios pretty much that we consider to then continue all the way to a college degree to reap the sheepskin effects associated with it. That's different for type 3, where if we can get a strong movement, given the rewards structure of individuals, into increasing the education, of course, there's much more room to further increase education, but it's much, much harder to get them into this funnel from high school all the way to college. So that's just as a kind of example of how we then learn something about the workings and the economics of the model from the prediction uncertainty. All right, and then we come to the decision theoretic ranking of the policies, and I'll conclude. So the main takeaway message here is then it depends what kind of decision criteria I adopt. And in particular, if you think about type 1, who ranks worst under the as-if optimization criterion, he then starts, or those kinds of individuals start to look more and more favorable as we emphasize worst case outcomes into our consideration over our uncertainty sets. All right, how many minutes do I have? -1 or? Okay, so then let me just conclude. So one is exactly trying to address the comment that you gave me here earlier, generalize our work building on asymptotic optimality theory in statistical decision theory. Second is address the computational burden of our analysis using surrogate modeling and adaptive sampling methods. And finally, then afterwards, incorporate some ideas from this global sensitivity analysis, trying to learn about what parameters of our models are responsible for the main bulk in the prediction uncertainty, to then maybe collect more data of them or learn more about these parameters from using other data sources. And finally, then coming back to Jaroslav's presentation, of course, we can then also think about how to incorporate these ideas of local misspecification into the constructions of our uncertainty sets. And that's it. So thank you very much. Looking forward to your questions.
Yes. Have you explored a fully Bayesian approach to this, where you would put a prior on the primary space? So the question is, have you thought about the fully Bayesian approach, where you would put a prior over the primary space and update it to posterior using the model and sort of report back to the policymaker the posterior distribution over the uncertainty, reflect the uncertainty of the prediction with a posterior distribution over the predictions?
Yes, so there's, I mean, some people in the audience have much more experience there, but my reading of the literature is that there's this disconnect or this separation between the Bayesian approach to estimation, which is mainly pursued in macroeconomics, and the more frequentist approach that we're doing here in the structural microeconometric realm. So I don't know exactly if there are any very valid reasons are. There's not that many papers. Michael has some of them, one of them at least, where he also tries to do the Bayesian estimation instead, with all the sensitivity analysis that then requires, of course, as well for the choice of the prior distribution.
So you have to fix this alpha, but the probability of, it feels like this, the way you're doing it now, doesn't fully reflect that, you're not equally uncertain about your point prediction and possible thetas that are at the ends of your confidence interval for theta.
No, with this, I'm particularly concerned about the with the max-min criterion, for example. I'm particularly concerned about the worst case realizations, right?
So that's one type of decision.
Exactly. Yeah.
If you report back a posterior distribution, that's a lot of information that kind of very well summarizes the full uncertainty about the primary space and the implications of policy. I mean,
Charles Mansky is always writing in his books that policymakers want a number. So maybe that's where your your posterior distribution. Yeah, I know. With the mean, for example, yes, or the minimum. Yeah, but you're definitely right. Okay.
Can we take a question from Joseph, which seems to be pretty much related to the discussion here?
Yeah. Okay. So if I were attacking this problem, and I try to do this now all the time, I would say, bootstrap my counterfactual, get myself a 95%, confidence interval or something, right? Which, isn't as sophisticated as what you're doing, of course, but it does help quantify the uncertainty in the counterfactual analysis. There are theoretical reasons why. Well, I can see there are theoretical reasons to prefer what you're doing. If you were to just bootstrap the Keenan-Walpin type estimates, do you have a sense of how different the answer would be if you were to just get standard errors on the counterfactual?
No, the reason that we're doing in this approach is kind of to bridge the gap between the high computational demands that these re-estimations would then consume when you're doing the standard bootstrap approach.
I see. Yeah,
it's really that's why we take this example here, which has like a reasonable computational burden where we can do a lot of checks and everything, but at the same time using or re-estimating these models, that's going to make it even worse. So we are now trying to kind of address, given that we're already relying on the asymptotic distribution here, to improve the kind of the numerical toolkit that we have to in particular these minimum realizations.
Right, but if
estimating.
Right, and if I could take a derivative of my counterfactual with respect to the parameters, and it wasn't too expensive, I wouldn't necessarily, like, where am I then? If the computational demand isn't too burdensome.
We didn't get the first part of the question. Was it regarding a derivative? So more looking at the local properties here?
Yeah, suppose I don't bootstrap, but I applied the delta method to get my asymptotic distribution of the counterfactual.
Yeah, so that's the keyword that I wanted to hear. So the delta method does not apply generally in structural models when we have those kinks in the predictions. Okay, so for example, here in the, if we study this class of policy alternatives, so implementing a tuition subsidy, we're bounded by 0 by just the mechanics of the model. So people not increase or do not decrease their schooling just because they get a tuition subsidy. So we have a kink at 0, and that's where then the application of the delta method does not work. And you also see it for the plot in type 1 and type 3, because for type 1, the delta method probably works quite well, right? It's then for type 3 where we get closer to this kink where we then, the linear approximation does not work.
Cool, that's a good answer, thank you.
Thank you. Yes. Michael, go ahead.
Oh, Philip, could you go back a few slides to where you showed the 4 different types? Stop. No. Go forward again. One more. There. So I'm just thinking this way of showing it is a bit maybe deceptive, because what's going to happen is that if one of these effects are low, all 4 are going to be low, and if one of them's high, all 4 are going to be high. I assume I don't think there's any way that you could change the parameters of our model to make one of these go way up and the other way down.
Yeah, so you would ask. Yeah, so that would be a good alternative to do, for example, once we fix ideas to type 1 and type 3, right? Look at the correlation of the predicted effects.
Yeah, if you're just looking at 2 types, you'd probably find there's a very strong positive correlation between the magnitude of the 2 effects, right?
And we do.
And that strong positive correlation will matter for a lot of the sorts of policies we were thinking about, because we were looking at things that might be able to benefit. The type 1s are rich and the type 3s are poor, so we're sort of looking for things that might help the 3s.
Yeah, or then you would try
Yeah.
to, for example, kind of hedging. If there were a negative correlation, that would be great. Then you could kind of hedge against the different outcomes, right?
Yeah.
So
Yeah.
that would be then a policy mix, trying to protect against this uncertainty.
So I guess it would be good to look at just the 1 and 3 and a bivariate plot here.
Yeah.
Right. Yeah.
Thank you.
I think we should move on.
All right, then. Thank you very much.
Great. Thank you very much for being here and for the opportunity to present today. Today, I'm going to present a project titled Breaking the Commitment Device, the effect of home equity withdrawal on consumption, saving, and welfare. And this is joint work with my co-author Agnes Kovacs at the University of Manchester and IFS. In this project, we're going to focus on housing, which is the largest asset owned by most households. In the United States, for instance, the median household keeps approximately 70% of its wealth in housing. Between the 1980s and early 2000s, housing wealth became substantially more liquid. During this period, it became cheaper and easier for households to tap into their homes and extract home equity using a variety of different mortgage products. And these developments were driven by a combination of financial innovation and liberalization. But to what extent is access to home equity beneficial for households? On one hand, there's a clear benefit. Access to home equity makes it easier for households to smooth consumption and self-insure against shocks. On the other hand, there also exists concern, especially amongst macroprudential policymakers, that home equity withdrawal may lead to overborrowing and overconsumption. And in light of these concerns, many countries have taken the somewhat extreme step of deciding to prohibit home equity withdrawal almost entirely. This includes countries such as Germany, Singapore, and Japan. Our goal in this project is to better understand the link between consumption, saving, and housing, and then to assess both the positive and normative effects of giving households greater access to home equity. The main hypothesis that we're going to evaluate is that housing may have traditionally acted as a savings commitment device, but cheaper and easier home equity withdrawal may have weakened the commitment benefit of housing, potentially making it more difficult for households to save. The key mechanism that we're going to build into a structural model and then evaluate is that it may be difficult for households to save in liquid assets due to problems of self-control. As a result, housing may act as a commitment device if it helps households lock away their wealth due to its illiquidity. Now, I should note right now that this is not an entirely new concept. It's just one that has historically been difficult to pin down in the data. So for instance, Robert Schiller says that one nice thing about investing in a house is that you're committed to a mortgage payment. And so if you don't take out a home equity line of credit, you will accumulate wealth. And this is going to be the idea which we want to build into a model and then evaluate in the data. So our contribution in this paper is first to develop a model that can capture not only the positive, but also the potential negative effects of giving households greater access to home equity. On the positive side, we have the traditional consumption smoothing channel, where access to home equity makes it easier for households to self-insure against shocks. On the other hand, we're also going to allow for the potential weakened commitment channel, where access to home equity may result in temptation for households to extract and consume home equity for short-term gratification. We're then going to take our model to the data to disentangle the relative importance of these two very different channels. We're first going to estimate the preference parameters of the model using data on consumption growth dynamics to pin down the importance of temptation compared to something that we're more familiar with, such as impatience or taste for housing. Then, after estimating the model, we're going to validate the model estimates by exploiting a policy reform in Texas, where they legalized home equity withdrawal in 1998 after more than a century of prohibition. And Texas was the only state in the US which had this sort of prohibition, and so it provides a nice experiment to test whether our model gives good quantitative results. Finally, we're going to use our model to study the implications for welfare and policy. And here the key question we want to ask is, to what extent is greater access to home equity beneficial for households? We're going to evaluate the welfare trade-off between commitment and flexibility, but then we're also going to consider alternative policy options that may better balance this trade-off. So just to give a brief preview of our main results, we find that home equity withdrawal weakens the commitment benefit of housing. In both the model and the data, we find that the legalization of home equity withdrawal results in a 3% increase in non-durable consumption, which implies a relatively large 2.5 percentage point fall in the personal savings rate. We're able to use our model to decompose the different channels which may be driving this response in consumption and saving. And we find that weakened commitment explains roughly half, while improved consumption smoothing explains the remainder. Second, somewhat surprisingly, we find that the welfare cost of weakened commitment is about 1.5 times larger than the benefit of improved consumption smoothing. Essentially, what's going on in the model is that home equity withdrawal makes it more difficult for households to save for both precautionary and retirement purposes. However, we do find substantial heterogeneity in the welfare effects. So in our baseline estimates, we find that about 2/3 of households are harmed by financial liberalization, giving them greater access to home equity, but the remaining 1/3 actually benefits. So where does this leave us? What are the implications here for policy? Countries have traditionally taken two very different stances when it comes to home equity withdrawal. On one hand, we have countries like the US and the UK, which have gone to great lengths to make this cheaper and easier for households to access. But on the other hand, we have countries like Germany and Singapore, which have decided to prohibit it almost entirely. What we find in our estimated model is that neither of these two extremes are optimal. Instead, we should try to design policy to better balance this trade-off between commitment and flexibility. So to give just one example of this, we find that it would be welfare improving to force households to repay their mortgages during good times, but to provide greater flexibility during periods of financial distress. And I'll give some examples of this later on, but we think that this result's especially interesting because it lends support to recent mortgage forbearance policies implemented during the COVID-19 crisis. So today I'm going to describe the model, our estimation strategy, and model fit both in and out of sample. And then finally, I'll briefly touch on our main results for both welfare and policy. We developed a life cycle model of consumption, housing, and mortgages, where households get utility from consumption and housing. They can save in either liquid assets or illiquid housing. They can borrow using long-term fixed rate mortgages, and they can extract home equity subject to a refinancing cost. Now, in the model I just described, access to home equity would be unambiguously beneficial. More choice is always good. And so in order to get around that kind of strong assumption, we're going to have to include two relatively novel features. First, we include temptation preferences, which may make it costly for households to accumulate wealth. And as a result of temptation, housing may potentially act as a savings commitment device that households can use to reduce their temptation. In order to do this, we're going to use temptation preferences developed by Gould and Pessendorfer. What these preferences say is that there may exist a tempting and feasible alternative in your choice set that you do not choose, but that still impacts your utility. So essentially, they're relaxing the assumption of the independence of irrelevant alternatives. And as a result, households may have a desire for commitment, where they'd like to reduce temptation by locking away their wealth. Now, I should note, this is not the only way to do this. The main alternative is to use hyperbolic discounting developed by Strauss and popularized by Leibson. But we think that temptation preferences are beneficial for two reasons. The first is that they allow for model-consistent welfare analysis, something which is simply impossible under hyperbolic discounting. And second, temptation preferences have testable implications for consumption growth, which are going to allow us to pin down their importance in the data. So what does this look like? Households maximize their expected discounted utility by choosing consumption and housing each period. Here, C and H represent households' actual decisions, while C tilde and H tilde represent the most tempting consumption and housing alternatives. The most tempting alternative is defined as that which maximizes your current period felicity, given your currently available resources. So in other words, if you knew you were going to die some point in the future, what would you do? Under Gould and Pessendorfer preferences, the utility function is then defined as the combination of the felicity you get from your actual decisions and this red term, which represents the utility cost of self-control. This is essentially the gap between the felicity you could get if you were only living for the present and the felicity you actually get from your actual decisions. And here, the key parameter is lambda, which represents the degree of temptation. If lambda is equal to 0, then we're back in a traditional model where more choice is always beneficial and home equity withdrawal can only possibly help households. And so our key challenge in this paper is going to be to disentangle temptation from other factors such as impatience or taste for housing. And finally, households are allowed to choose mortgages each period. And here they can choose both their actual mortgage debt, M, but they can also be tempted by the possibility of extracting home equity. Now let me briefly describe the asset structure in this economy. Households can save in liquid assets, A, which for now we assume must always be positive and give a certain return R. They can also invest in illiquid housing, where we assume that housing is a discrete asset within different sizes. So, a small flat, a house, a mansion, etc. And households are allowed to own or rent in a unit, where rent is simply a scaled down version of the house price. And adjusting your housing stock comes with two different transaction costs. First, you have to pay a financial cost to moving, but in addition, you also suffer a utility cost, which represents the pain it is in order to put all your life in boxes and find a new place to go. Finally, households can borrow using long-term fixed rate mortgages, which is the predominant form of mortgage contract in the United States. We assume that mortgages are given subject to a maximum loan to value ratio, denoted by psi bar. Mortgages are fully amortizing, meaning that they require fixed repayment each period until either the period that you retire or the period that you sell the house. However, they allow for the possibility of home equity withdrawal, subject to both a multiplicative and an additive cost. Finally, there's a number of other additional features of the model, which I'm not going to describe today because of time, but let me just briefly outline them. Housing can provide a utility flow, which we're going to estimate later. Households face exogenous income and unemployment risk throughout the course of their working lives. Households are subject to progressive income tax, which includes a realistic housing subsidy and Social Security payments after retirement. And finally, household composition varies over the life cycle. So now let's jump into estimation. We're going to use data from the panel study of income dynamics between 1999 and 2015, and we're going to adopt a two-step approach to estimation. Where in the first approach, we calibrate the standard institutional parameters related to income risk, asset returns, and refinancing costs. And then in the second step, we estimate all of the preference parameters of the model using the method of simulated moments. And here the key challenge is going to be to differentiate between temptation and impatience. And this is something which has historically been very difficult to do. And as a result, most macro models with temptation just have to put a finger in the air and guess what these parameters may be. So in order to estimate these parameters, we're going to target a combination of life cycle and aggregate moments. So on the life cycle side, we're going to target mean non-durable consumption for each age between age 25 and 60. We're also going to target log liquid assets over the life cycle and log net housing wealth over the life cycle. On the aggregate side, we're going to target things such as the share of homeowners, the share of extractors, the share of movers, the average loan to value ratio, and finally, the relationship between consumption growth and liquid assets. And now let me zoom in a little bit more on our motivation for targeting this last moment, because it's going to be key to our identification strategy. So the key insight for identification is that temptation alters the relationship between consumption growth and liquid assets. And you can see this if you look at the Euler equation, which governs consumption growth dynamics in our model. What the Euler equation says is that if households give up 1 unit of consumption utility in the present, they're going to want to be compensated by a certain amount of expected discounted consumption utility in the future, but they're also going to be harmed by greater costs of temptation next period, where here C tilde is the most tempting consumption alternative. And of course, if we turn off temptation, if we set lambda equal to 0, then this final term in the Euler equation disappears and we're back in a world where we're much more familiar with what things look like. And this Euler equation is going to hold for any households with liquid assets that are positive. But what does this look like? In this figure, we plot expected consumption growth on the vertical axis and liquid assets on the horizontal axis. And the dashed line comes from the traditional model without temptation. And it actually looks exactly like what you see in Chris Carroll's famous buffer stock model. What you see in that model is that households who are near the credit constraint have high expected consumption growth due to the fact that they'd like to shift resources from the future to the present, but they're simply not allowed to do so. But in the traditional model, as you get further away from the credit constraint, we see that there's essentially zero relationship between consumption growth and liquid assets. And this is due to the well-known finding that expected consumption growth in such a model is determined entirely by your preference parameters and not by your asset holdings. In contrast, the solid blue line shows consumption growth dynamics in the model with temptation. And what we see is that temptation alters the relationship between consumption growth and liquid assets in two different ways. The first is that temptation depresses consumption growth relative to the traditional model. This is because temptation introduces a disutility to accumulating wealth. Therefore, households want to consume more in the present and less in the future. Second, we see that temptation generates a positive relationship between consumption growth and liquid assets for households who are away from the constraint. And essentially what's driving this is that households who have higher liquid assets also have higher optimal per period consumption, and as a result are going to be less affected by the cost of temptation. And if we go back to the Euler equation, we can see this by the fact that C tilde is affected by, is raised to the power of negative gamma. So this is simply coming from the fact that there's diminishing marginal utility to consumption and thus diminishing marginal costs of temptation as you consume more. So how are we going to take this insight and estimate the model? What we're going to do is we're going to operationalize this using the following consumption growth regression, where on the left-hand side, we have the change in log non-durable consumption. And on the right-hand side, we have log liquid assets and a series of age controls. What we show in the paper is that in the model with temptation, there's a positive psi, a positive relationship between consumption growth and liquid assets. And moreover, more temptation implies a larger psi when you hold all the other structural parameters constant. In contrast, in the model without temptation, we find that there's a negative relationship between consumption growth and liquid assets, regardless of what you set in terms of the discount rate, risk aversion, or taste for housing. Now, one challenge I should note right now is that we have to deal with credit constraints. So in the baseline estimates, we're going to estimate this consumption growth regression on a restricted sample of households who have liquid assets greater than $500. And this is going to be a restriction that we apply both the model and the data. So essentially it's in an indirect inference framework. But we found that our results are robust on various hosts of alternative constraints, which we've explored in the paper. So now let me show you the results in terms of model fit. This figure shows the fit of the life cycle profiles that we target, where the solid black line comes from the model and the blue dots come from the PSID. We see that the model does a good job at matching the gradual accumulation of liquid assets and housing wealth over the life cycle, as well as the hump-shaped profile of non-durable consumption. In addition, this table shows the relationship between consumption growth and liquid assets in our model. In the PSID, we find a positive relationship between consumption growth and liquid assets. And we spent a lot of time trying to see if we could break this result, but we found that this result is robust to the inclusion of a whole host of additional controls, such as household or year fixed effects, or controls for family size, habits, or inheritances. In our baseline model with temptation, we're able to obtain a good fit of this targeted moment, whereas in contrast, in the restricted model without temptation, we're simply unable to generate a positive relationship between consumption growth and liquid assets. And this is essentially a well-known and old result, including in the buffer stock model of Chris Carroll, there's a slightly negative relationship between these two variables. Thank you very much, by the way. So now let's turn to model validation. So I've shown you how we estimate the model and I've talked through our identification, but now let's see if our model does a good job at predicting actual behavior when we have some sort of change in policy. So to do this, we're going to exploit a policy reform in Texas, which legalized home equity withdrawal in 1998. Prior to this reform, Texas was actually the only state in the US which had such a prohibition. But the policy was changed following a close constitutional referendum, which happened just 2 months prior to the reform's implementation. what we're going to do is first document the effect of this reform on consumption and mortgage behavior. And to do this, we're going to use data from the Consumer Expenditure Survey between 1995 and 2003. And we're going to estimate the average treatment effect using a difference in differences specification. Due to time, I'm not going to go into much of the details today, but in the paper, we have a number of placebo tests and also event study where we're more formally testing the parallel trends assumption. After doing this, we're then going to implement a similar policy change in the estimated model, which is going to allow us to assess its out-of-sample predictive power. This table shows the main results. In the data, we find that the legalization of home equity withdrawal results in a 3% increase in non-durable consumption for homeowners in Texas relative to homeowners in other neighboring states. We see that the model obtains a relatively similar 2.6% increase in non-durable consumption for homeowners. In contrast, we see that the reform has simply no significant effect on renters in both the data and the model. And in addition, we see that the model and the data have relatively similar predictions when it comes to the intensive and margin of mortgage adjustment, although slightly different predictions when it comes to the extensive margin of mortgage adjustment. So now that I've talked about estimation and shown you that the model has good out-of-sample fit, let's turn to the main question here, which is welfare. So the key question we want to ask is whether the cost of weakened commitment outweighs or not the benefit of improved consumption smoothing. This table shows our main results. We find that the welfare effect of legalizing home equity withdrawal in our model, we find that the legalization of home equity withdrawal in our model actually reduces welfare by about 1.4% in terms of consumption equivalent variation. This is because the cost of weakened commitment is about 1.5 times larger than the benefit of improved consumption smoothing. Now, in our baseline results, I'm assuming that the social planner has the same utility function as the households, but we may be interested in an alternative where the social planner ignores the psychic costs of temptation and focuses only on the utility that households get from their actual consumption and housing decisions. Even in that case, we find that the cost of weakened commitment outweighs the benefit of improved consumption smoothing. We're also able to use the model to look at the response in terms of households' actual behavior. So for instance, we find that the legalization of home equity withdrawal reduces the personal saving rate by about 2.5 percentage points. And we actually think that this is relatively large when you think that the US savings rate used to hover around 9 or 10% in the 1980s, and then reached a low of about 1 or 2% in the mid-2000s. But interestingly, we're able to use our model to decompose the different channels driving this response in consumption. And we find that within our model, weakened commitment explains roughly half of the reduction in the savings rate following financial liberalization. So what are the implications here for policy? The key question we want to ask is how should we design and regulate mortgage contracts? And there's actually a very large finance literature which is looking at this question under alternative trade-offs, such as when there's interest rate risk or when there's house price risk. But a novel thing which we're able to do is look at how we should design mortgages when there exists this trade-off between commitment and flexibility. So we're going to use our estimated model to evaluate 4 potential policies. The first is the baseline policy where home equity withdrawal is fully permitted. The second is an alternative where home equity withdrawal is permitted, but subject to a debt to income cap, similar to the policy implemented by the UK about 6 or 7 years ago. The third is a policy where home equity withdrawal is fully prohibited, as in Singapore. And the fourth is a policy where home equity withdrawal is prohibited in normal times, but permitted during periods of unemployment. And of course, this final policy has never actually been implemented in the real world, but this is one of the benefits of having a structural model. We can analyze these sort of policies, which we just have yet to see in reality. But I should note on this last policy that there are some states in the US which have implemented policies to give households greater access to home equity during unemployment. And so there is actually some discussion on how this could be designed. So what are the results of these different policies? This figure shows the savings rate under these 4 potential policies. In our baseline, we see that households save roughly 2.5% of their income each period. We find that any of the 3 alternative policies increase the savings rate. And if the government simply wants to increase the savings rate, the way that they would do so, to increase it the most, is by having a full prohibition on home equity withdrawal, similar to Singapore. But as we're going to see in just a moment, this is actually not the optimal policy. So this figure shows the change in welfare of each of these different policies relative to the baseline where home equity withdrawal is fully permitted. What we find is that the policy which improves welfare the most is the final policy where households have state contingent access to home equity. In contrast, we find that a debt to income cap actually reduces welfare relative to the baseline. So why is this? Essentially what we find and what we discuss in more detail in the paper is that it's welfare improving to provide commitment during good times, but also flexibility during bad times. And the economic intuition for this is that the marginal benefit of flexibility is highest when households' income is low, whereas the marginal benefit of commitment is highest during times of, of good resources. And, this also helps us understand why the debt to income cap reduces welfare. Essentially what the debt to income cap does is it restricts households from being able to tap into home equity when their income is low. But this is exactly when home equity withdrawal would be most beneficial for households. And so we really think that that policy is not the way to go. Now, let me just say that there are multiple ways that we could design mortgages to provide this form of state contingent flexibility. In our model, we've been looking at allowing home equity withdrawal based on individual level unemployment. And this is similar to the mortgage assistance programs, which have been implemented in states like Pennsylvania and Connecticut. And what these states do is that they give you a home equity loan if you've lost your job in order to help you make ends meet. But another way that this could be done is by providing forbearance based on the state of the aggregate economy. And this is similar to some recent suggestions by Campbell, Clara, and Coco, amongst many others. So in conclusion, we find that greater liquidity has weakened the commitment benefit of housing and that the cost of weakened commitment is substantial. And therefore we should design policy to better balance this trade-off between commitment and flexibility. Thank you very much.
Well, thanks for your presentation. I have a question. I'm not quite sure, and please correct me if I'm wrong, but you mentioned that you have a liquidity constraint on liquid assets, but you're restricting your analysis to those who are not affected by the liquidity constraint. So in a way, you're restricting or taking out the group that benefits most from additional liquidity in consumption smoothing. So I have a feeling that you're kind of taking out one very important group. Those are who are liquidity constrained or hand-to-mouth consumers who would largely benefit from having more flexibility in their liquidity, and maybe don't suffer so much from the weakened commitment. So could you elaborate on that?
Thank you. Yeah, that's a really important question here. So a key assumption for our identification strategy is that there's no heterogeneity in temptation. And if there were heterogeneity in temptation, then you're absolutely right that the most tempted households would also end up being the households with exactly $0, and therefore they'd be excluded from our consumption growth regression. So if there do exist these more tempted households, then in the real world, then our estimator is actually going to be biased slightly downwards in terms of the importance of temptation that we estimate. So in that way, I would say that this is a relatively conservative approach because we may be excluding the people who are most tempted. But in terms of our estimation strategy, essentially what we're trying to do here is we're trying to deal with the fact that there's not a good analytical mapping between the Euler equation and the data. So this is due to the fact that there are credit constraints, and for that reason, we need to take an indirect inference approach. And one of the benefits of the indirect inference approach is that we can have an auxiliary model, in our case, the consumption growth regression, which is misspecified. In this case, it's just being estimated on people who have more than $500 of liquid assets. But as long as we apply that restriction, both on the simulated data from the model and the true data coming from the PSID, we're still going to get a consistent estimate of the structural parameters. And actually going back to the earlier presentations that we had seen on estimating models with both continuous and discrete choices, I guess in a way, this is the third option on how to estimate such models. It's by using indirect inference. you build into the model this sort of discontinuity, but then you target moments which allow you to try to get around it. Thanks.
Thank you. We have a common question from John Rust in the chat as well, but since we have luxury of actually, talking in person, let me walk all the way here.
Yeah, I'm with you that there are some controls, but in housing, there's it's complex because think about COVID. People had lost their jobs. If you prohibit them to extract their home equity, you really hurt someone, right? So if you're wrong that this is that people have self-control and you put this policy in an inflexible way, you could actually do a lot of damage too, right? So how do you think about that? I mean, how certain are you that the housing is done for this way?
Yeah, John, that's a great question. And, initially when I was working on this project, I was coming with this rather negative policy conclusion of like, oh, maybe we should just outlaw home equity withdrawal. And I felt like this cannot be where I leave the project. And so ultimately, I feel like we should not do that. So instead, I think we should try to design mortgages to give people more flexibility during periods where they have financial distress, either they've lost their job or we're in a recession, but try to force households to build up a little bit more home equity during normal times. And there's actually been some interesting policies in Sweden where they're trying to get people to do that. So in Sweden, they have mandatory amortization, which they implemented maybe 6 or 7 years ago, but they relaxed it. They relaxed it during the COVID-19 crisis. And I think that this is a good way of doing it because then people actually have more home equity by the time you enter into this crisis. But then you give them way more flexibility when they really need it, and when you can stimulate the aggregate economy using it. So I think we should definitely not outlaw home equity withdrawal. We should just try to encourage it more during bad times and less during good times.
So just in terms of the model ingredients, you have both liquid and illiquid housing wealth. And so just in terms of, I'm thinking through another policy in terms of whether this would be welfare improving in the context of this model. If, for example, home equity could be extracted, but only to invest in the house. Part of me thinks it's almost unambiguous that would be welfare improving. I think Juan's Pitano's comment is somewhat similar.
Yeah, so I absolutely agree. And so in this model, we're really looking at the trade-off between consumption smoothing and weekend commitment. And we're ignoring one of the big benefits of home equity withdrawal, which is investment. You can extract home equity to invest in your home or to pay for your kids' college tuition. And so in that regard, I think there are other large important benefits of home equity withdrawal. And actually with that policy change that we were looking at in Texas, they had always allowed households to extract home equity for the purpose of home improvement. That was the only reason for which you were allowed to extract home equity prior to 1998. And so for that reason, we wanted to build a model in which we're not really looking at that side of things, where we're just looking at the other forms of non-durable consumption. But I think in terms of the policy recommendations, we would nuance it a little bit by saying we should have state contingent access to home equity or home equity, which is being used for one of these investment purposes. And the way that was implemented in Texas is that you'd have to go to the bank and show I'm doing a renovation, and then they'd give you a home equity loan. So it can be done as well. Great question. Thank you very much.
Okay, thanks so much for having me here. I really wish I could have been there, and I'm very jealous of you all. I look forward very much to your comments, and please have no shame about interrupting me. Yes, okay, so I'm going to tell you about what I'm calling a structural meta-analysis. You're going to see that this is a very straightforward application of techniques that we know, or that we mostly know. I just think this is a nice name for what I'm doing. ultimately. Okay, so the setting that I want you to imagine sort of generally is that you have estimated treatment effects from a number of experiments, all in the same field of interest, but perhaps with differences in the way they're designed, okay? So I'm going to focus on experiments in what I'm doing, although conceptually there's nothing special about the experimental nature. These could be, you know, as we sometimes do in meta-analyses generally, these could be just generically studies, quasi-experiments, and that kind of thing. Okay, and so what we want, the reason meta-analyses exist is that we want to be able to aggregate the information that we get from these experiments, okay? And in particular, the reason typically we want to do this aggregation is for policy and prediction. We don't want to just continue running experiments for the rest of time. They cost a lot. They you know, often don't identify the parameters that we're interested in ultimately. And we perhaps like to design future experiments also more effectively. So these are some of the motivations we have for wanting to bring sort of a more formal analysis of experiments that we've seen in related work that I'll discuss. So that's our want operator, is a way to aggregate. And so in this paper, what I'm going to do is show that you can use the results from multiple experiments, say, to estimate a structural model. And this is one way of doing aggregation that is actually nested quite nicely in sort of the general framework for meta-analysis. The nice thing about the model, of course, is that these differences in experiment design, if they make sense to write down in an economic model, can be used for identification and are actually quite important. So differences across experiments are useful, not a nuisance, as they sometimes are in traditional meta-analyses, and I am going to say more about that. My application, though, is on welfare reform experiments in the United States. I'm particularly interested in the labor market impacts of these reforms, and also the impacts on child development outcomes. Okay, it's a topic of interest for myself. Okay, so I'm going to jump straight into talking about methodology. Here's what I want you to imagine. Y sub k here is a vector of statistics. I'm assuming that they'll be coming from an experiment that is collected with some sort of randomly assigned treatment variable, but it could be any study. Little k is going to index, little k exists to denote the fact that we have many of these experiments and we want to put all the information together, right? And so generally what I would like us to also keep in mind is that we have some parameter of vectors gamma that we're interested in, and these index a class of models, let's say index the population framework, okay? And in particular, the population limit of these statistics, for example, the treatment effects, is defined by this model, okay? And for the sake of regularity, what we'll want to assume is that these statistics are asymptotically normal. Now, what we know is that if we want to put together all of our information to identify the parameter of interest, gamma, well, we can just use minimum distance, right? So if I stack all of my outcomes here, Y is, I take all of the statistics from every study, I put them in a big vector, and I stack my model predictions, okay? I'm just going to choose gamma to minimize some weighted sum of squares. Okay, so to fix ideas, in a traditional meta-analysis, these Ys are just differences in sample means. They're treatment effects. And this M is just usually summarized by one parameter, the average treatment effect, right? It's just a linear model with an average treatment effect. And then the solution to this sum of squares problem is to take an average, is a weighted average, okay? And that is what not all, but most meta-analyses end up being, is a weighted average, typically where you've chosen W to be efficient, right? So you use the inverse of the variance for all your studies. Okay, so this is a nice way to aggregate information, but I've written this in a way where there's no need for M to be a model of an average treatment effect. M could be an economic model, okay? So this is what I just told you. In a traditional meta-analysis, The Y's and the M's, Y's are mean impacts, M is a linear model. There's usually one parameter of interest, alpha, the average treatment effect. Often, there are differences in the way experiments are designed or implemented. So more than just sampling variation, say. And this is treated as a nuisance parameter, or as, nuisance variation is what I'll call it in that literature, because you're really only interested in one number and you're assuming that there is one number that summarizes the population average treatment effect. Okay. If you have, you can write down more sophisticated models, use Bayesian methods, to try to discipline the way you're adding up. And I'm going to take these methods and try to extend them. But the bottom line, of course, is that we may not always be interested in alpha as a parameter. And for policy and prediction, we know there are parameters that could be more of use to us. Okay, so let's throw out the linear model just for the sake of argument. And let's now let gamma index policy invariant primitives. Okay, so preferences, technology, and so forth. Now, all of a sudden, any differences in the way an experiment is designed could be useful to us for identifying the parameters of this model. And now outcomes of interest, particularly, welfare and policy outcomes, are articulated for any sort of counterfactual that we can cook up that is that makes sense, let's say, inside of our model. And we know this, well, we know this ex ante, but we've also seen great applications of this in the context of single experiments, Todd and Walpin being a classic example, Atanasio, Miguel, and Santiago being another one. Both of these studies used data from the Progressa experiments in Mexico. Okay, and we can apply the same frequentist or Bayesian methods that are used in traditional meta-analyses. So this is hopefully a fairly clear description of the methodology I'm going to employ here. So in my case, I'm just going to collect statistics, publicly reported and available statistics Y from many studies. I'm going to write down an economic model of the outcomes, and I'm going to estimate the model, right, using this distance criterion. So really not fancy at all, but I think in terms of using an economic model to aggregate policy evidence or policy information, I still think that what we do, which is useful, is underutilized in this sphere. And so one reason I'm doing this, well, there's two reasons. One is I wanted to see for myself how well this would work, but also kind of push this idea that this is a domain of comparative and relative advantage for us in terms of aggregating information for policy. Also, I'm not very good at getting cool data, and it often makes me mad to see other people use awesome data that I can't seem to get. And so part of this was also me challenging myself to say, well, how much can you do with other people's data when they just tell you what averages are and what statistics are, what treatment effects are? Okay, and my conviction is that we can still learn. We can learn a lot. Obviously, you can do more if you have the microdata. So that's a tautology that I won't be able to argue against. Okay, that's methodology. I told you the application here would be welfare reform in the United States. The only really important thing for you to know is that many states used randomized control trials to evaluate the policies they had in mind prior to welfare reform in 1996. Okay, and what I'm doing today is not me personally, I hired some RAs to do it. The companies that evaluated these programs, they produced long reports with many tables, with many averages and standard errors. So I had some RAs go out and collect everything that could be useful to us, and we compiled it into one data set, okay? So those are the Ys that I showed you before. It's all publicly available information, importantly, okay? The other thing that I want you to keep in your mind about these experiments is that there are really 4 choices in the way the experimental welfare programs were designed. One is just benefit formulae, so for every dollar somebody earns, how do we tax, or how do we reduce their welfare payment? Okay, And in many cases, what we saw actually were wage subsidies in some of these experiments. Time limits on participation, usually in the form of a lifetime monthly limit. Work requirements, which I'm going to model in a specific way that I'll tell you about in a couple of slides, and childcare subsidies. Okay, and basically, none of the experiments were implemented in the same way. They all varied in terms of mainly these 4 choice variables. Okay, and you can see already that these are things that are easy to articulate in an economic model and will give us useful information about underlying preferences and elasticities. Okay. And that's what I'm going to do. I'm going to exploit specifically that variation in the way the experiments were designed to identify what I think are the key parameters of the model. Okay, the counterfactuals I'm going to look at today, because I told you the reason we want to do this is for policy and for evaluating counterfactuals ex ante, which we know is a great thing we can do with structural models. I'm going to do a couple of things. The first is just to look at the effect of a $1,000 unconditional transfer to households. That's particularly important when we think about child outcomes. It's a counterfactual that seems to be a benchmark in the literature when we think about how important is household income for child development. So if we give households an extra $1,000, what do we think is going to happen to cognitive skills, behavioral skills of kids? How important are resources, financial resources? I'm going to also look at a policy reform where I get rid of all the other things that were going on and look only at work requirements. And this is going to be a way to try to disentangle the effect of work requirements in welfare reform specifically, relative to time limits and changes in benefit formulae and so forth. And again, what I'm interested in really is the impact on kids, both academic and behavioral outcomes for kids. So that's what I will focus on, although in the paper I spend some time thinking about labor market impacts more generally. Okay. Great. So I'm usually bad at getting to the end, although I'm really going to try today. So I'm just going to tell you some results now. That $1,000 transfer that I told you about, for the estimates that I get from aggregating information from experiments, it looks like they would lead to a 2 to 3% standard outcomes. This is quite a bit smaller than what I think of as the prominent estimates in the literature for this, at least when we think about direct monetary resources. I would say probably the best, and perhaps you know of another study that I should be citing here, but I think Dahl and Lochner is the best sort of existing estimate there, and it's maybe 2 to 3 times bigger. In terms of the behavioral effects, there's a nice paper, quasi-experimental paper that gets a similar number. So I'm in the ballpark in terms of what exists, although, these are experimental. This is, I'm using explicitly experimental variation, although we could quibble about how I'm doing the adding up. I'm still using a model to do that. So we could argue about my specification of the model. I'm going to find that when we impose work requirements, that there's no significant impact on kids, at least not in most sites. Ultimately, this is because what you're doing with these work requirements is you're getting mothers to work more, so they earn more, and you don't see much of a net change in household resources in terms of time and money. And so there's a balancing out for kids. And that, I think this was a source of concern during the welfare reform era. And it looks as if, at least this specific program feature didn't necessarily have negative impacts on kids. Finally, and this one is puzzling to me, I should say, all of this is preliminary. There's some things I want to do before I resubmit the paper. But I'm going to estimate, contrary to some of my own work and some other great work, Mike and Raquel Bernal have a series of papers looking at this in, using different methodologies. I don't find evidence in these data of a negative impact of non-maternal care. That is to say, ceteris paribus, if a single mother goes to work and her kid stays home or uses whatever form of care is available, I'm not finding negative impacts from that counterfactual. That's something that I'm still getting my head around, but it is what it is. it's in the data, I think. Okay. So here's the goal I'm setting myself here, since I'm telling you that I'm going to estimate a model using statistics, mostly averages, right? Some standard deviations. We want to try to make the mapping between the model parameters and those statistics really clear, especially to the average treatment effects. So I'm going to do my best to do that for you today. Let me tell you about the environment. Since overwhelmingly participants in cash welfare are single mothers, I'm just going to assume that that's the agent in the model is a single mother, and her endowment is just a fixed number of hours every week. So no savings in this model. I already told you that the experiment site will be indexed by K. J will always refer to the particular treatment arm. You know, typically there's two, there's treatment and control. At a few sites, we see multiple versions of multiple treatment arms. So J could take larger values too. And we have time T. I'm going to assume that the investment period, that is the number of years in which a mother is investing in her child, is 17 years. So we have an annual model here too. Okay. The choices being made every period are whether to participate in welfare, whether to work. If a mother is working, she has to make a choice about how her child will be cared for. She's either going to choose formal care or informal care for the kid. And then when she's not at work, she has to decide how to spend her time at home. She could either do that with housework, Q is the variable there, or she can spend time with her child. That's what I'm calling time investment. That'll be indexed by tau or denoted by tau. And she can either consume privately or spend some money on her kid. Okay, so the dynamics here are coming from two sources. There's an investment problem. So I'm trading off my private consumption today against the skills of the child. And if we live in a state, or if I'm in an experiment arm in which a time limit has been imposed, that's implicitly a save there today or save it for the future. Okay, so those are the two dynamic components to this problem. This is somewhat important, so I'll spend a minute on it. Here's how I'm writing down preferences, and in particular, everything in orange here is something that's, if you see something in orange in the next few slides, it's a component of the problem that's being manipulated by assignment to treatment. So here, R is going to indicate whether a work requirement exists for an individual at site K in treatment arm J, although I forgot to put J in here. Now, there's two ways this can work. I'm going to model work requirements as a pure hassle cost. So if I'm participating in welfare and I don't work, I pay a cost, alpha R sub K. If I'm participating in welfare and I do work, it may be possible that work requirements help me make employment less costly. This alpha R2 exists because we know, in many sites, work requirements came in the form of employment services. So if you weren't working, you would have to go and spend 15 hours a week or 20 hours a week in training, or, sometimes that was literally just, I'm going to watch you while you apply for jobs or whatever, right? So those are the two ways that work requirements are going to show up here. Okay, if you know more about, if you know something already about welfare reform, you may have some opinions on this, but I'm going to I'm going to move on, and then I'll be happy to talk more about that modeling decision. And of course, we have some IID shocks, taste shocks to all the discrete choices that are being made here with nested logit structure, okay? So sigma H and sigma F are going to key parameters that determine elasticities of work behavior and the responsiveness of formal childcare use with respect to the price of childcare. So the resource constraint is as follows. WQ is the productivity of housework, okay? And so that allows me to combine everything into one resource constraint. Importantly, though, we have the price of childcare, which is getting manipulated by subsidies, potentially. And we have the income function, which I'm just writing as YKJT. This just tells me given your participation in your work decision, and given that you're in site K, which was associated with a particular wage, your net income is something that's manipulated by both the labor market you're in and the policy environment you're in, which is subject to your assignment to control or treatment, but also the year. We're going to see lots of wage growth through the 90s. So T is important here also.
Joseph, sorry to speed you up. Let's say we have 10 minutes, but let's leave some time for discussion.
Okay, all right, thanks. Appreciate that. I must love the sound of my own voice more than I realized. Okay, I'm going to speed right on up, and I'm going to tell you that here, I'm not going to explicitly write down a technology of skill formation. I'm going to assume that it's Cobb-Douglas in the outer aggregator, but the inner aggregator, I'm just going to specify in terms of a price of investment. And there's 3 prices depending on whether I stay home with the child, whether I use informal care, or whether I use formal care. And so when I say that I don't find negative impacts of non-maternal care, what I mean is that the relative price of investment when my child is in formal or informal care seems to be about the same. So that's the model. And even though I promised you that I would give you a really clear understanding of this, I was obviously lying because I didn't give myself enough time. In general, though, I think I'll at least pitch to you the basic idea, which is quite intuitive here, is going to be I'm going to allow for site level heterogeneity in work and participation behavior. That's all identified from control group means. And then we have a number of parameters that are key in determining the responsiveness of behavior to incentives. So the responsiveness to time limits, the responsiveness to wage subsidies, the responsiveness to work requirements and childcare subsidies. And those are global parameters that we're going to estimate by doing the adding up. Okay, we do get a lot of analytical solutions for things in this model, and I'll point you to paper to get more of a grip on that. But there's a fairly clean sort of identification type thing going on here. Okay. So I already told you, we go out into these reports. There are 15 to 20 of them for 5 experiments, and we just greedily take everything we can that we think is going to help pin down the model, and we're going to assume that we have this approximate asymptotic normality. We're going to use that to form an approximate likelihood, essentially. And I'm going to use this hierarchical Bayesian method, which is considered the frontier in terms of meta-analytic techniques. The basic idea is that you have global parameters that, for me, either apply to the model or govern the distribution of site-specific parameters. And I'm going to specify all my priors very loosely, since I'm generally a person who has no idea how the world works. Okay. So, yes, I'll tell you a little bit about this, since I did claim that I was really interested. So here is the reduced form sort of outcome for the expected realization of child skills as a function of stuff that mothers are deciding. Okay, the key parameters here are delta I, which summarizes the importance of household resources for a family, for the formation of skills. Okay, G, remember, G without the hat was the price of investment given for a given care arrangement. G hat is the log relative price ratio. So I'm dividing both of the two. Think of G naught as the sort of the normalizing factor here. There's normalization, and so if this G hat is negative, it means that there's a positive impact of, say, non-maternal or formal care on child outcomes. And if it's positive, then that relates to a negative impact. Okay, and so here's my graph of my posterior for delta I. For kids who are younger than age 9, what this the way you can interpret this is that the modal estimate, a 1% increase in resources, that's dollars and time converted to dollars, leads to a 0.22% increase in skills. It's hard for me to interpret what that really means, so I'm going to reinterpret all of this through that $1,000 counterfactual in a couple of slides. But here are the posteriors on those relative prices. And so this is the price of non-maternal, price of investment under non-maternal care relative to maternal care. And you see that it's very evenly distributed around zero, the posterior, which is what I mean when I say I don't find evidence of negative impacts, excuse me. There's some marginal evidence that formal care has positive developmental impacts on kids. Okay, so I'll finish with some counterfactuals and hopefully that'll give me a minute or two for questions. And in fact, I'm just going to show you the one and I'll wrap it up because this is the one I claim to be most interested in. Here we see that effect of a $1,000 transfer. This is the overall behavioral effect. So not just the direct effect, but also, you know, any ensuing effect on work behavior and childcare. And we see that 2 to 3%. I've got the confidence sets in here, so you can see that we're definitely not close to some of the other non-experimental estimates in the literature. Work requirements here, we can see that 0 is inside pretty much all of the confidence sets, and there's a lot of variation because, of course, initial conditions matter for these counterfactuals too, and the initial conditions will be different from site to site based on the labor market conditions and so forth. Okay, so this is just one example of what you can do with this framework. There's a lot more we could do. What I didn't do and would like to do in the future is discipline some of this with representative data, microdata, to sort of think more generally about what the overarching population framework here is. I mentioned it, but I didn't give myself enough time to really help you see it. I mean, heterogeneity here is all at the site level. And ultimately, or ideally, we'd probably like to model heterogeneity at the individual level, which would require some microdata that I don't have, though I think I can still do it with public data rather than groveling for the experimental microdata. Okay, so sorry for losing my voice. I was at a wedding last night and I think I had a little too much fun. But I'm eager to hear your thoughts and questions.
So I see one question by Thomas here, and I'll give you a mic.
Thank you very much. Very interesting project, Joseph. So I just have a question, sort of like, how do you think about inference? But I asked that before you showed all these confidence sets and all that. But I'm just curious because sort of all these moments, right, you get from different studies. So how do you think about that, sort of the covariance between them?
Oh, okay. Well, so the way I would think about that is that, well, what I'm going to assume. Oh, well, there's two versions of that. Let me go back to, I guess we have it on the first slide. You know, across studies, we can assume that the variation in the moments are independent, right? Because we have, you know, this is all just sampling variation. So as long as we're doing IID sampling, we can assume independence. Within a study, that's important, and it's a great question. The best we can do without the microdata is use the model, you know, do it in kind of 2 stages and use the model to estimate what the covariance would be given the sample size. So that's sort of the technique that I use to correct for the fact that I won't see the covariance between, say, labor force participation and program participation within a site. You know, but the model will tell me what that covariation should look like once I have the estimates, the first stage estimates. I hope that answer made some sense.
Thank you. Okay, there is another question from French.
Yeah, so I was just curious to what extent the structural model can be used to reconcile all the disparate findings and these experimental evidence. To me, that almost seems like the key value of the structural model is to try and understand both in terms of differences in observables across the different experiments, as well as a lot of these differences in terms of some of these different experiments are very forward-looking.
Yeah, that's a great point, and I do need to do that. So I suppose the way to do that, I've only gone one way, and I haven't gone back to look at how well am I predicting treatment effect outcomes across sites. And hopefully I'm not doing a terrible job. I think some of the things are quite intuitive. Even if you just look in the raw data, you can see that, you know, there are sites where you see women working more, but they're barely replacing the income they lost from going off welfare. And so it's not hard to see that in those places, you're going to see either no impact or negative impacts on kids. But in terms of the labor market stuff, I really need to look more carefully at that. But thank you for reminding me, because that's important.
All right, thank you very much. Are there more questions? Oh, Mary Christine, do you want to unmute yourself and just go ahead?
Yes. Joe, I think you assume that there is only a participation margin, no choice of hours by single mothers. I was wondering, first, how in the data does the distribution of hours worked by single mothers look? And second, how does that impact your estimates and findings, do you think?
Yeah, that's a very good question. So we won't, I mean, I don't have specific numbers, but we both know that the distribution of hours worked in the data won't look like it does in the model. One reason for making that decision was that there's no evidence across the sites of any increase in the intensive margin. So there doesn't appear, so to some extent, I will be missing variation within the data in terms of hours worked, but I don't think that it will lead me too far astray in terms of predicting treatment impacts, because there aren't seemingly significant changes in hours worked, conditional on working, between control and treatment groups. Ultimately, I think I will, in order to appease referees, I will have to put in an intensive work decision anyway. But for this first pass, the lack of evidence of a treatment impact motivated me to focus on the extensive margin. But I didn't answer your question. I don't know how it would mess up my results, other than the loose conjecture I just made. Sorry.
All right, let's thank all the participants again. Thanks a lot.